All right, test, test, test. Good morning, everyone. I'm trying to get into the classroom here. I'm going to go briefly in game, so I'm going to double broadcast for a second. Good morning, everyone. I'm arriving. Hopefully everyone is set. I'm double broadcasting at the moment. I'm going to go strictly to YouTube now. All right, still in game. There we go. Let me get myself up on the podium. Okay, hopefully we're all here. Let me just check to see who's in range. All right, let's see. My radar says we've got Ben D, although Ben D, I saw you out by the DNA arriving at the moment. Ben, Faith, Ben A, Trent, Sam, Ben, Toby, Monty, Thomas, Carson, Dee Dee, Morgan, Adeline, Landon, Matthew, Ethan, and Dodger sitting there. Like to see Dodger there. And as I look around the classroom, see Dee Dee over on the right, Morgan, Landon, Luke, Faith arriving, Thomas, Matthew, Toby, Sam, Trent, Ben F, Ben A, and Adeline. Good to see everyone. All right, let's just take a second and run through our checklist to make sure that we're ready to participate in class. First item, find a quiet location. Make sure your roommates know that you are in class at the moment. Next item is to make sure you've got your headphones on so that when you speak, we don't get a bunch of echoes. I'm going to open my chat so I can see feedback in chat from you. Shut down any extra apps you have or any extra browser tabs you have if you're playing some movie in the background or you've got some game. Uh, Sam asks if I'm speaking yet. Go to Go to game. I am speaking, but I'm speaking through YouTube. So if you could click on the screen behind my head, I'll stop double broadcasting here in a second. I can hear you if you speak in game, but I'm turning off my in-game mic so we don't have double broadcast through the laggy YouTube and here. So Sam, you got that? Okay. Anyone having trouble with the YouTube broadcast before I go out, turn off in-game audio? Yeah, you're getting double because I'm in broadcasting in-game and YouTube. I'm going to just go through YouTube now. Okay, so shut down any extra apps or browser tabs that you have so that you are able to use your CPU for the game. The next one is to make sure you have a Canvas window open so that you can attend to any due dates or anything. Make sure that you have VPN activated. As I look around, I see most of you have got a little dot over your head, meaning that your VPN is okay. If you haven't turned on your VPN, you're going to need to leave Firestorm for a second, turn on VPN, and go from there. Dee Dee says clicking on the screen isn't getting me to YouTube, so clicking on the screen behind me isn't working. Let me just give her a link. So clicking on the screen behind me should activate the YouTube play. It might take a moment for it to start shuttling in, but I dropped a link in game so that you can check to make sure that it's going to work generally. If the link in game, if the link I dropped in the chat works outside of the game, it should work fine in game too. Might take a second to load up. Okay, if everyone could go through and rebake their avatar, I look around and some of you are invisible people. So again, to rebake your avatar, you go under Avatar, Avatar Health, and Force Appearance Update, and that'll make sure that we all, in a second, have all of our textures applied to our avatar. Ben Doklas, if you could apply an avatar that isn't quite a nuclear glowing cloud, I'd appreciate that. It's just a little bit distracting to have this ultra creative avatar over there. What I'll do is I'll send you a avatar from my inventory real quick so that you have one that you can work with. Let me see if I can do that. Share and share to Ben. All right, so you should get a request, you should get an offer to share from me, and you can put on that avatar for the time being until you get a chance to do something that's more fun, but not quite as glowy. Okay, next thing, make sure we set our environment so we're in a consistent state. So under world and environment, select midday, and that'll just make it so that we're all experiencing the same time, which is roughly noon in game, although it's a little bit earlier in real world. You guys are all in the classroom. If you are in the world, and oh, one other thing actually. I'm broadcasting in game now for a second. It occurred to me, Dee Dee, that if you are not able to see the YouTube video on the screen behind me, there's one other in-game setting that you might have to set, and that is in the upper right of your Firestorm browser. There's a very small volume icon that if you hover over it, it will show you multiple sliders where you can mix the audio input from all the different sources. And you need to make sure that the media slider over on the far right, that there's a checkbox checked next to the media slider, and that will make sure that media can play in the game. And you need that checkbox checked for the YouTube video to play behind me. Okay, so make sure you also have your classmates' name tags turned on so that you can see who else is in class and who's speaking. And the way you do that is you go under Avatar, Preferences, the General tab on the left, and there's a whole section on name tags, and you can click on, and then you have a bunch of options for like what what you want in that particular set of name tags. What I would like to do is I would like to set up a group with everyone in it so that I can message the group independently of the other classes that are meeting here. But I don't want to take a moment to do that. Okay. All right. And last thing is just to check to test audio. So let's try going off, turning on your mic and just saying something out to the world. We're all going to talk over each other, but let's just give it a shot and make sure a mic is working. And I'll look around and make sure I see green coming from everyone. Great. All right, so that's good. And if you notice, the audio is spatially aware. So the people that are on your left come out of your left ear, and the people that are on your right come out your right ear, and that's kind of fun. All right, so let's get rolling on class today. Here's where we are. We are in chapter 1 of Big Java, and we have a couple things going on. So let me see if I can get that up here. All right, this is our book. Let's look at our calendar for a second on Canvas. Calendar, what we see coming up is today we have some daily work. Today's daily work is going to be to do kind of a Hello World program, but I'm going to ask you to output instead of Hello World your name. And then I'm going to ask you to submit one file. It is a text file that will end in .java, J-A-V-A. That's going to be where we're heading towards today. The other thing that we have coming up is a Techne assignment due on Monday. That's going to be like in CS-10. We're going to do Techne and Episteme assignments that are similar. These are just getting us into the flow. Chapter 1 is an introduction, and so it's going to give you an overview of Java, an overview of sort of architecture of computers, things that you're probably familiar with, but it's just good to get us on the same sheet of music, as you, if you will, accept that metaphor. And then the assignment on Wednesday is to do an extended version of what you're going to turn in today. Again, it's just going to be an extended version of a Hello World program where you're going to output a small, fake picture to the console. As some of you may find that somewhat pedantic, some of you may find it challenging because you've never used Java or the Eclipse IDE, and so that's fine. I don't expect you to have used it before. But for those of you who would like to do something a little bit different, in addition to doing those two, there is a challenge assignment with some skeleton code for making a song. And so there's some code in there for being able to play a song using MIDI, if you're familiar with the MIDI interface. And a third option for something you can turn in is a program that plays music, plays a song that you program in. So that's an option as well. All right, so One thing that we didn't get a chance to do is to finish talking about some of our policies. Again, I'm not going to go through all of them, but I would like to make sure that we get through all of them eventually. And I think last time we were talking about our learning objectives and our tools. I'm going to assume we started with tools and keep rolling from there. I'm a little confused among the different classes with how far we've gotten on this. So our tools are Canvas. We're using that for our gradebook and for class material assignment distribution and for class calendar. We're using Westmont's webpage for campus policies. We're using Google Calendar for office hours scheduling. So Google Calendar will be where you can make an appointment with me outside of class to chat about things. Using the VPN that it looks like most of you are connected to. Discord is going to be a backup for us if the virtual campus should go down for some reason or we otherwise have difficulties with working in the world. We will also use Slack. Now, I tend to use Slack for just text communication. It works a little bit better for me than using the text communication in Discord. So I'll use that. And I'll use that often in class in order to communicate text things in class, sending links and whatnot. I'm also, of course, monitoring chat in game. If you throw a question up there, I'd be happy to answer it at any point. And in fact, you should be aggressive about asking questions because it's hard to get the synchronization of everything down right. And I will, as I see your questions pop up, I will roll those into my presentation. Email, of course, and then the Eclipse IDE, and we're going to try and work with Saros, and we'll get to that eventually. All right, next thing to touch base on is announcements. The main place where I'm going to put announcements is in Slack in the class channel. So if you need to set up some kind of mobile version of Slack on your phone, or you need to set up notifications, or you need to somehow change your just daily practice of when you are sit down to do your work, or when you, I don't know, when you check your messages to just run through Slack and to make sure that nothing has changed with respect to, with respect to what's going on in class, I suppose. I will tend not to use email for announcements, and I will tend not to use Canvas for announcements. They just get too cluttered. Slack is a pretty clean place to go and look and find archived information, and we can put additional resources there. The calendar, I use the Canvas calendar extensively. As you can see, as I click through on the YouTube stream right now, I'm showing the calendar. This is a great place to go to see what's due. If it's not in the calendar, I'm not expecting it to be due. And if I say something is due and it's not in the calendar, you can call me out on that and say, hey, I didn't see that in the calendar. How come it's due? And I'll give you a little bit more space to take care of that. The modules reflects the work that we're going to be, I didn't mean to do that. The modules reflects all the different work that we're going to be going through in the course of the class, basically going through different chapters in the book. I'll post lecture notes there as well. Grading and studying. So grading consists of class attendance. So for example, today, the way I'll be measuring that is turning in your Java program. Eventually, I'm going to get a widget in game so you can check in when you're in game for attendance. You'll have the Techne assignments. Those are the multiple choice assignments that you can do multiple times, and I'll take your highest grade for those. And those are an opportunity for you to evaluate how well you're doing on reading the textbook and following along in class. That'll be 15% of your grade. The programming assignments or the episteme assignments, the knowledge building assignments will be 30% of your grade. And so we'll have one per chapter, roughly one per week, except we have a couple misses because of holidays and exams. And we'll have 3 exams, each of which are cumulative up until the information that we've covered at that exam. Each one is worth 15%. The 3rd exam is the final exam. I think, like when I plan my classes, what I'm expecting to have happening when you all are working in your on your own with the different resources that you have to study is I'm expecting that for every hour in class, you're going to be spending 3 hours outside of class studying in some way. That can include reading the textbook, reviewing whatever lecture notes that you're taking on paper and pencil probably as we're going over this work. And I recommend you do jot down notes about things to follow up on, things to ask me about, things to look up after class as we're going through the class online. Some of that time will be spent trying some of the techniques on your own, even techniques that maybe aren't being evaluated or techniques that aren't part of the homework. It's helpful to solidify your learning by practicing in the programming. Of course, working on the techne assignments and working on the episteme assignments. By the way, that 3-hour assumption isn't something magic that I made up. That's sort of a standard assumption about college level classes that you spend 3 times the amount of time. The expectation for accreditors and educators and curriculum developers is that there's 3 hours, 3 times as much time spent outside of class as in class working on the work. We're going to be learning the Java language. We're going to be learning Eclipse. Those are sort of the way down in the weeds skills we're going to be using, but the more important skills that we're going to be using are learning how to think computationally and how to use computational data structures to get work done. Because our goal, of course, is not to learn programming, it is to use programming in order to accomplish things in the world, in order to more or less build God's kingdom, as long as we understand that broadly understood, right? Um, Letter grades are based on a Canvas gradebook that is built into the system. You can check that out. Class participation, I would like everyone to be in game when we're going through our work. That's because at various points I'm going to have us do things in game that leverage the environment. And you have to be there to do that. And also, I think it's important for a sense of presence for everyone being here. It's important for our little community that we have a sense that we're all present and working together. And it's just better than Zoom. For participation, automatically 3 of your participation grades are going to be dropped, and you don't have to explain that or anything. That's just because, I don't know, you had to pick up someone at the airport, you overslept, whatever it is. It's a little different than medical. Medical is in addition to that, provided we can confirm that. But the 3 is just so that I don't have to answer a bunch of requests for special exceptions because of just normal stuff that happens in life. Okay, so let's see. Attendance, I expect you to be in class. That's part of your grade. We'll do that through either just taking attendance or through participation stuff, participation activities. The Techne assignments are the same as what we had in the same style as what we had in CS-10, walking you through the chapters as I mentioned. I'm rushing through this a little bit because I don't want to spend too much time on stuff that you guys are familiar with. In particular, there are a few students in class who weren't with us in CS10. And for those students, please ask me to clarify if you feel it's necessary. You can also read what I'm blowing through here on Canvas as well. Our episteme assignments are programming assignments. They're due once a week, roughly 1 per chapter, as I mentioned. Very specific instructions in each of those assignments. They're all posted in Canvas that you can take a look at. Our exams, the structure of the exams will depend exactly on what the situation is at the point at which we take the exam. And when I say situation, I mean our COVID situation. My standard approach to doing exams is to have them be open note but offline, and to have some paper programming that we use when we are in class, as well as multiple choice. Given our online environment, some last semester we were required in various ways to do it all online, timed, and on your own, but online. And I prefer that to trying to do some sort of lockdown browser or showing up a tent, something like that. Let me give a brief pause to see if anyone has any questions at this point. And I know there's a lag, so I'm just going to awkwardly pause here for a second. Oh, and oh yeah, you are seeing this. Good. All right. Awkward pause. Yes, I'm gonna double book here. What do you got? All right, so for archival purposes, that was a question from class about why Canvas is showing that I have a bunch of zeros for assignments that haven't happened yet. And that's because Canvas is applying a late penalty because it thinks that the assignments were due in 2018. And that's just because when I launched the class, Canvas attached 2018 to all the assignments. I'm not sure what happened there. So as I go through and update the assignments and publish them, those zeros should go away. Okay, let's do our last, for today, let's do um, our last what? Let's do our last class administrative bit on late penalty. What the late penalty is 1% per hour after something is due. Most things are due at 11:59 on the day at night on the day in which they're due. And if you continue working on it after that, there's a late penalty of 1% per hour. So it's not a hard cutout, it's a soft cutout. The longer you wait, the more penalty you have, such that if you were to turn it in 24 hours late, you would have a 24% penalty. Sometimes that helps to accommodate crises or, I don't know, just fixing stuff up at the last minute that will bring your grade from an 80 to a 90 if you take one more hour. And for those of you who want that to make that trade-off, you can do that. Okay, let's shift gears. That's enough course administration for today. We'll finish the course admin later, but I want to make sure that we don't sacrifice our discussion of the topic that I really care about talking, which is about Java. So Java is my favorite language that I've worked with. I like it a lot. It's a highly structured language. It has a lot of overhead, meaning that the tools that we use are kind of heavyweight, and that's because it's a very professional language. It's used for very um, sophisticated programming tasks, if you will. Um, we don't start with it though. We first teach Python because that overhead is very overwhelming for students, and so we don't want to present students who have never seen programming before with a really elaborate environment like Eclipse in order to do our programming. Java is the most widely used language professionally in California. We did a marketing survey about 2 or 3 years ago, and it came out as being the language that most people that are doing software development are using in California. And that's at like the 65 to 70% level. That may surprise you because it's not the sexiest language that's out there. You know, the languages that you hear a lot about are the languages that have a lot of initiatives around them to build. You might hear things about Go or Erlang. You might hear about Node or oh, Python, for example. Yeah, these are all growing languages, but they're not established quite as heavily as Java. So it's good to know a variety of languages, and we're going to focus on Java in this class. Um, First couple bits of the introduction is about basics of computer structures, and I don't want to spend too much time on it, but I do want to make sure that we reinforce the structure of our computer architecture. So we'll talk through that a little bit. And what we want to learn from this first chapter is just generally about compiling and running our Java program, thinking a little bit about computers and programming, and just revisiting ideas about pseudocode and the different kinds of errors that we might run into. As you are familiar with, computers are programmed to perform many different tasks. They are called general purpose computation machines, and that's different than devices that just do one thing. For example, maybe an airbag controller in your car. It may have a small computer in it, but it doesn't run multiple programs. It just runs the airbag launcher that detects if you're in a crash and fires off your airbag. A lot of cameras, for example, are single-use computers, although some people hack them so that you can play Tetris and various video games on your Canon single lens reflection camera, SLR camera. But the kinds of computers that we're working with tend to be general purpose computers. So your computer can run Firestorm and it can run Eclipse. The things that make computers powerful is that they run simple instructions very fast and appear to be doing them multiple things in parallel, although at any given moment, a single core on your computer is only running one instruction sequence of them that the programmer puts together. And so what programmers are doing is they are writing these lines of code that the computer is going to execute. And so it's almost like a programmer is a translator between a human intention and what the computer is able to do. And the programmer is structuring the instructions so that the computer will do what the human intentions are. And there's a little bit of a boundary between what a computer can do and what people want the computer to do. And programmers are the ambassador between those two perspectives. Collectively, we call the things that you can touch and feel, the physical components, that's hardware, the keyboard, the screen. But the things that that are ephemeral, that can exist in multiple different places, are software. So that would be your programs that exist as text. In many ways, software is like a story, and that an algorithm or a way of doing things can exist in someone's head, and that can be independent of which computer it's actually running on. Eventually, you have to get what's in your head into the computer itself, and we do that through programming languages. But software itself is like a story. It exists in the collective imagination of people, and then we reify it, we make it real when we put it into a text file, and then we execute it on hardware. And if you think about software as a story, if you think about software as something that exists in the collective understanding of all of us as people, it's really sort of a phenomenal metaphysical kind of thing. And I think that's really an interesting spiritual aspect of the way that programming operates. Um, when we think about what kind of requirements a computer that's going to play a music CD might have, that's a CD being the hardware disk that plays music. It's not Spotify, it's old school Spotify. Such a computer would need some kind of program that can control the hardware that reads that CD, take the data off the CD and translate it into audio through the speakers or through the screen. So there's hardware and programming working together to make a CD play music. A CD player itself, something that exists like a portable CD player or the CD player maybe that you still have in a car somewhere, less flexible than a computer. Why? Because it can only do one thing. It plays music CDs. And so in that sense, it's an impoverished computer at best, or we might not even call it a computer because it only does one job. In contrast to what a programmer does, someone that wants to play a video game does not need to know how to program. A user of a computer isn't a programmer. A user of a programmer is not a developer. A user of a programmer we typically think of as someone who gets to work with the product that a programmer creates. Now, in the course of this class, that can actually get a little bit confusing because sometimes when we're in the context of a programming class, when we're thinking about programming, we'll sometimes talk about the user, and we mean the user being the programmer. So, like we'll talk about how the user of Eclipse. Who is the user of Eclipse? Well, the user of Eclipse is the programmer that's writing the program in Eclipse. And so if you are ever confused about what I'm talking about when I say user, please ask me to clarify because sometimes I will unconsciously shift between the understanding of a user being someone who is not familiar with how to develop software and is using the product of a developer from a user being a programmer who is using programming tools. And while they're both users in their own sense, we typically think of someone who is uninformed about programming as being the ultimate user. If you're familiar with Excel, Microsoft Excel, or you're familiar with, I don't know, a variety of other tools, there are a lot of ways in which people who you typically wouldn't consider being software developers have the opportunity to program. And a spreadsheet is kind of an entryway into being a developer because when you enter formulas into a spreadsheet, you're shifting gears from being sort of an uninformed user of a spreadsheet to someone who's starting to write programs as you write formulas in spreadsheets. Very simple programming, but it can get more and more elaborate as you dig into the contents of a spreadsheet, for example. Okay, basic anatomy of a computer. This graphic is a little messed up. I apologize for it, but we have the central processing unit of the computer. That's the chip. When you buy a computer, you often are making a decision about what chip you want on your computer. Apple just released a set of computers that have a new architecture of a chip called an M1 chip. That is a physical component roughly the size of a postage stamp or maybe 4 postage stamps that do the main computation of the low-level data manipulation that we work with. And we call that the CPU, the central processing unit. It controls the flow of the information, of the instructions. It controls the flow of the data through your computer, and it works with storage. So storage is going to be what we would typically call your hard drive, although your hard drive may be now solid state drive. Whatever medium you're using for storing things, when we talk about primary storage and secondary storage, we're talking about places where you can store things for a short period of time. That would be primary storage. Primary storage goes away when you turn off your computer, and secondary storage remains archival when you've turned off your computer. So if you turn off your computer and turn on your computer and you can get your English paper back or you can get your program back, that means that you stored it in secondary storage. Maybe that would be a flash drive connected to your computer. Maybe that would be the hard drive on your computer, or maybe that would be the solid state drive on your computer. Secondary storage is long-term storage. Primary storage is like the RAM on your computer, the things that are, for example, keeping your programs running while it's in operation. Finally, we've got peripherals. Peripherals are those things that help us to get input and output from the person using the computer. Our screens, our audio, our keyboards, our mouse, our tablets, our microphones, all those things that interface between people and the computational virtual environment are considered peripherals, printers, for example. And finally, we've got the network. The network is what connects the different computers together. So we typically think of this as the internet with air quotes around it, broadly understood. But the internet consists of a whole bunch of different components that are working together to create the illusion of seamlessly connected computers. The networks you could think of as including Wi-Fi. You can think of it as the software that's running on your router, but there's a lot of work that's being done in order to make sure that our computers can work together and can transfer that software back and forth across the internet. Here's a picture of a CPU. This is the underside of a chip. All those yellow dots are pieces of metal that connect the chip to the rest of the computer so that information can go into the chip through those metal bits. And the piece in the center is where all the all the work is done. Whenever you have information moving on or off the chip, you need a much bigger wire than you do internally, and that's why such a large part of the footprint of the chip is dedicated to getting things on and off the chip, because the physics of getting data on and off a chip require larger wires. Hard disk, this is one that has a spinning disk. It's like an old school vinyl record. It's encased within a square, and it has a little arm that reads things. This is secondary storage, so a hard drive is going to retain information when your computer is turned off. More recent computers, slightly more expensive computers, are going to have a solid state drive where this spinning disk is replaced with just chips, basically a whole bunch of flash drives that are inside your computer. And the advantage of that is you don't have any mechanical components. Nothing is moving on the solid state drive. That enables it to be a little bit more robust against dropping your computer and just the kinds of failures that mechanical devices have in general. This graphic, unfortunately, is a little bit cut off, but this is an architectural idea of how computers are structured. And it is kind of a model for how programmers think about computers. And it's pretty independent of whether you're talking about a laptop, a desktop computer, or a smartphone. Those four vertical lines that you've got in the middle are called a bus. They're the place where all the information is exchanged, and it is a common place where that is shared by all the different components that connect to the bus. It's called a bus. It might be better called a highway, but it's called a bus because of the idea that like a public bus would move up and down this road, transferring data, which might be in that bus, from one place to another. So if your CPU needs information from your secondary storage, it has to request that information from the disk controller, get it from secondary storage, and pass it back to the CPU, and that information will travel over the bus. And while the information is traveling over the bus, information from like the microphone coming in from the ports can't get into the computer at the same time. Now, the reason why this doesn't end up being much of a problem is because the bus is operating so much faster than human perception that if you're playing music, for example, and the CPU needs to get something from your disk, the music is playing so much slower than the information that's being transferred between the CPU and secondary storage that you don't even notice. So that's why this works at human scale. All right, so where is a program stored when it's not currently running? Answer to that, it's stored on secondary storage. Let me shift gears here to in-game and ask you the question in-game so you folks can answer. So in-game, I am chatting now. I'm going to turn off my audio. Okay, so computers are everywhere. You've got them in your cars, you've got them in the things that you're carrying, you've got them in your appliances, you've got them in all kinds of stuff. So we're talking about a skill that is applicable to all over the place. Some of our first computers included the ENIAC, which was an early computer that, when it turned on, caused the power grid to dim all the lights in the houses nearby because it sucked up so much power. And it's worth mentioning here that some of the first computers were used by the military in order to generate ballistics tables. And if you're familiar with the movie Hidden Figures, it tells the story about computers moving into NASA to do the orbit projections. I think I've got that story right. Um, Moving into NASA to project the orbits of spacecraft. Um, the important thing that I want to draw out, though, is that the word computer itself wasn't always referring to the hardware. The first computers were actually the women who worked as mathematicians in these government agencies, manually computing ballistics tables and orbit tables. And so when the computers were introduced into these environments, the women who were doing the math associated with computing these ballistics tables were put out of a job, and the computers were doing the job. And so what happened was is that these women became the people that were the first programmers. So as the computers took over their job, they very naturally became the people that ran the computers. And so while they were no longer the computers, they became the first computer operators and computer programmers. An interesting thing happened in the early 80s, which is that computer game systems started coming out. And when computer game systems started coming out, they were put into department stores and different places, and they were put in the toy aisle. And the toy aisles, if you've ever been in a department store, have these really strong gendered characteristics. You walk down one aisle and it's filled with pink uh, dolls and pink boxes, horses and kitchen things and Barbies. And then there'll be a boy aisle that's black and dark blue and green, and it's got asteroids and space action figures and war, different things like that. And department stores are adjusting this over time, but certainly you've had this experience. When those first video game consoles were released, the marketers had to decide which aisle they were going to put them in. Were they going to put them in the boy aisle, or were they going to put them in the girl aisle? And the marketing decision was to put them in the boy aisle. And at that point on, computer programming, the domain of computers, became very heavily gendered towards young men and males in general. And the initial history of computers being run by women was lost for a long time. And um, that has been to the detriment of our industry and is something that we still really, to be honest, haven't fully recovered from. And so there's a lot of gender bias in software development. There's a lot of gender bias in software development companies, and a lot of people are aware of it, and some companies are doing something to work towards trying to support that. And so at Westmont, what we're doing to try and support that is, first of all, acknowledge that this is a thing, and try and use examples and domains for our programming that are gender neutral as much as that's possible. And the other thing we do is we have the opportunity to support women in technology, in which we have some outreaches that welcome just supporting women in technology in general. And we open that up to physics and some of the sciences as well. So stay tuned if you are interested in participating in that for announcements along those regards. Usually we try and do one thing a semester, like a lunch or something for that. So that's just an interesting historical note about the history of computers. Hidden Figures is the movie if you want to see some of the dramatic reenactment of that. Stop for a second, see if you have any questions or comments. Any questions or comments out there? Okay, rolling on. So Java programming language. Let's get rolling there. A couple things about the Java programming language. It is safe, and I'm going to put air quotes around that because no computational system is totally safe. And by safe, what we mean is that it is it has less opportunities for things like buffer overflow errors. It has less opportunities for security breaches because it was developed with some safety in mind. There are always opportunities for bypassing the security of programming languages, but Java does a pretty good job of that. It is a portable language. And when I say portable, what I mean is that the Java programming language can be used on any different modern operating system. So you can write a Java program and it will run on Linux, it will run on Windows, it will run on Mac, it will run on back-end servers, it'll run on Raspberry Pis, it'll run on a lot of different platforms. Um, I think it might not run on smartphones, but that's not because it can't run on smartphones. It's because the smartphone manufacturers don't allow it to be run, not because it's not possible to be run. Those are called walled gardens or environments in which not all software is free to run, not because of technical restrictions, but because of business considerations. The same reason why Parler was able to be kicked off of the different smartphone applications is the same reason why Java is not able to run in, for example, Google or Apple devices. It's platform independent. And the reason why it's portable and platform independent is because when you write a Java program, it is compiled into something called bytecode. And that bytecode is like a low-level language that's different than Java. And then there is a virtual machine that has to be implemented on every different platform in order for Java to run, in order for the bytecode specifically to run. And so when you downloaded that Java runtime environment for Windows, or for, I think some of you were on Linux, and for Mac, what you were downloading is you were downloading a program that can interpret the bytecode that is generated from Java and can be run on whichever chip that that your computer in particular has. And so what's not platform independent is the virtual machine, that JRE that you're running. That's not platform independent. You have to download a specific one for any hardware that you're going to run your Java program on. Once you have that JRE installed on your particular hardware platform, well, now you can run any Java program that was written on any other platform, and the JRE does the job of making sure that it works consistently across all the different platforms. And so that's great. It's a little bit like the way a web browser works. A web browser is specific to the particular platform you're using. You have to download a different version of Chrome for Windows or Mac, a different version of Firefox for Linux or Mac or Windows, whatever you have. But once you have that browser installed on your computer, you can look at any web page. It's the same architectural kind of distinction. Once you have a JRE installed, you can run any Java program. Java also comes with an enormous number of library packages, so there's not a whole lot of need to be reinventing the wheel for basic stuff. So things like encryption and network connections, presenting windows, and to some degree graphics, there's all kinds of libraries already written out there. So once you get familiar with them, you can actually do quite a bit of work in getting things up and running. All right. Designed for the internet. What isn't designed for the internet? All right, applets. You may run into this idea of an applet. An applet is a Java program that runs in a web browser. Almost no web browsers support this anymore because it was such a horrible source of security problems that web browsers have basically shut down applets. It's too bad, but it's just a fact of life. So if you ever run into the idea of an applet running on a web page, you can just kind of ignore that. Java versions, you guys installed Java version 11, and you can see roughly sort of what happened here. I mentioned this in office hours briefly with maybe Faith. I can't recall who it was at the moment, but originally when Java versions came out, they were numbered 1.0, 1.1, 1.2. You can see the years at which they were released. And at some point, we threw away that 1.1 and we started calling Java 1.5 just version 5, 6, 7, 8, 9, and we're up. I asked you to download version 11. Recently, Oracle, the company, has begun asserting intellectual property rights over the Java language again. And when Oracle started asserting intellectual property rights over the Java language, they began to accelerate the release schedule. And so while you can see there that there's like 3 to 5 years between releases up until version 9, more recently, new versions of Java have been getting rolled out kind of more like annually or semi-annually. And the flip side of that is each new release has less important things in it. It used to be that a new release of Java was a really big deal because the language was changing in a big way. More recently, as the versions of Java have been released, they've been kind of small and relatively not important changes for the level of programming that we're doing. So what we chose to do when we downloaded Java version 11 is we chose to download a version of Java that was a particular milestone. That Java version 11 is called a long-term support version, which means that the open source community that is keeping the open source version of Java running, that's what we got from the Adopt OpenJDK website. That open source version is going to be, that version 11 is going to be supported with security updates and security releases for many years, even as 12, 13, 14, 15, 16 get released past that. When the horizon for keeping security updates in Java version 11 sunsets, when we get to the end of that, a new version of Java will be identified as the long-term support version. Maybe that'll be version 20 when that happens. And at that point, if I teach the class again, we'll standardize on a more recent version, which is being kept up to date. But for the time being, version 11 is a good version to learn, and will be around for several years. All right, keep rolling. Hopefully we'll get here to what I want to talk about, which is getting our program written. So quick question, how long does it take to learn the entire Java library? Well, you can't, that's not really a goal. That isn't something that you should be trying to learn. That's something that you should be looking up through the documentation. It's really too large for any individual person to become an expert in it. If you do become a professional programmer or an expert hobbyist, expert vocational programmer, you may become very familiar with portions of the Java language, but it's unlikely that you'll learn in depth all of the different libraries that are available. It's just too big. Okay, so let me shift gears to Eclipse and walk you through what we need to get done today for our programming assignment. And let me just double check our time here. I have us going until 10:15. Yeah, that looks good. Okay, correct me if I'm wrong. All right, so in order to become familiar with our programming environment, what we need to do is we need to get Eclipse up on the screen for you. And so for Eclipse to be up on the screen, I am going to shift what I'm broadcasting on YouTube. And so as I shift to broadcasting Eclipse, I'm going to lose track of the chat in game. And so if you have a question, please unmute and just feel free to speak up. I know that that's awkward because it is requires you to sort of interrupt me, but that's just the way it's going to be. So just pipe up and we'll deal with the way in which online classes have to be for the time being. Okay, so what we're looking at right now is Eclipse. We ran through this very quickly, but we're going to reinforce it now. We have a bunch of different components here, and I'm just going to reiterate that over on the left here, we see a hierarchical arrangement of what you see in mine is many, many different projects. A project is the high-level component here, and if you open up a given project, you'll see a bunch of different components within it. Some of them are files that contain programs. Some of them are configuration elements. So this, for example, is saying which version of Java does this project run with. Later on, we'll see that there are other kinds of files and components here as well. You'll see that each one has a different icon indicating what sort of thing this is. And so at the top, you'll see a little folder with a J on it that indicates that this is a Java program. Eclipse can actually be used to run a lot of different languages. And so you may find that there are places where you can do things other than Java as well. Eclipse itself is an open source product, and so it is developed by volunteers. I like it a lot. A lot of people use some other IDEs. IntelliJ has one. There's some other ones that Android Studio is one that's run by Google. They're a little bit shinier and whatnot, but I just like I like quite frankly, I like the open source zeitgeist of the product itself. The licensing terms, just the freedom in the different ways in which that can be understood, that's associated with Eclipse. All right, so the first thing that you do whenever you write a new program is you have to create a project. And so the project is done by going up under File and New and Java Project. And you can go ahead and follow along with this, or you can take notes or you can refer to this afterwards to do the work that's required for today. The project is just basically creating a structured folder for you to put your source code in. And that project name can be anything. And so I'm going to go ahead and call it something associated with class. So I'm going to give it a date. I'm going to say it's class 01, and today's the 15th. So I'm going to create a project that has all the work for the class today. A couple different default options. Last time we looked at this default JRE, and we want to pick the open source or the Adopt Open JDK 11 that you downloaded, but that if it's not present, you have to install into Eclipse. And I can do that in office hours with you if you'd like, if you're unable to figure out the very detailed settings for doing that. The basic way that you go about doing it is by going under configuring JREs here. That's the entry point into the rabbit hole of installing it. You can hit the next button if you'd like. See some details here. This should be okay. All things being equal, the default should be all right. And if you hit finish, you'll have an opportunity to create a module-info file. And I just don't create that because it's not necessary for the kind of work that we're doing. If you do create it, it's not the end of the world, but later on you might find it's easier to not have that present. You should see a new accordion folder show up over here with the name of your project, which you can open. And we don't have any source code yet. And we want to introduce some source code here. And as I mentioned in last class, in Java, everything is object-oriented. So you can't run a program without first creating a class that will contain your program. In Python, we used classes, but classes were sort of an optional thing that you could use if it was convenient for the way you were writing your program. In Java, it's not a matter of convenience, it's a matter of structure, and it must be used. And so to create a new class, the way I prefer to do it, there are multiple ways to skin the cat in Eclipse, but the way I prefer to do it is to select the source code folder where I want my class to end up. That's over in the Package Explorer on the left. And then I want to right click on that, creating a context menu that's going to pop up, select New, and you'll see that I could create a new Java project, but that doesn't make a whole lot of sense because I already have my Java project. Instead, I want to scroll down to where it says Class, and I want to select that. I'll get a new wizard here, and I'm going to try and shift my YouTube screen. I'm going to try and shift my YouTube screen to see if I can zoom in on this. This is something I set up earlier, and let's see if it works. All right, hopefully that zoomed in. Package, we're going to give it a package, which is a reverse URL notations with a dot. So edu.westmont.cs30. That's going to create a folder structure for us on our hard drive where our source code is going to end up. The other thing I want to check is I want to check off here where it says public static void main string args. And when I check off that box, what that means is that this is going to be a class that can start a program. All Java programs start in a main method, and unless your class has a main method, it is not a place where your program can launch from. We want our program to launch from this class. So we are going to check that button so that a main method is automatically written for us when we complete this wizard. I look up here and I see a little error. It says the type name is empty. That means I haven't given my class a name, so I'm going to select the name field, and I'm going to give the class a name. As is the convention in Python and as is the convention in most object-oriented programming languages, the name of your class should start with a capital letter. And so I'm going to call this class hello, no spaces, world. I'm going to use inner caps, meaning the W in my class name is going to be capitalized as well. That's not as important as having the first letter be capitalized. That first letter being capitalized is a signal to Java and to other programmers that anything called hello world with a capital letter is in fact a class, and that's something that we have to keep track of as we're programming. When we do that, we're going to have a class folder automatically developed for us, and so that's going to show up over here on the left in our project folder. You'll see the package that we defined is also created for us, and our program is identified in our project folder. You'll see that our program actually has a little accordion as well, and even though hello world.java is a file, the way that the Eclipse IDE enables us to work with our code is it enables us to open up that file even deeper by expanding that accordion there. And even though we are now looking within a text file, because Java is a structured language, our program, our Eclipse IDE is able to give us access to different things within our programming file through the accordion structure in our package explorer. You can see that we're able to reference a particular class that's within our file, and that's indicated symbolically over on the left, in as much as it's also shown in our text file in the center. In any regard, what I want to do now is I want to go to the content of our program and edit it a little bit. So I'm going to shift over and zoom into that here. Zoom in a little bit. You can see that we have a comment that's automatically been generated for us. One way of doing comments in Java is with the double slash. You can see that we're using a special set of characters called to do, and there are other views within Eclipse that will show us all the places where the to do text shows up. It'll create a to do list actually with check marks that we can explore at another time. For the time being, what I want to do is I want to remove this comment and I want to put in the line that you need in order to complete today's work. And that work is, it's a little bit wordy. One of the ways in which Java is criticized is as being a very wordy language. We're going to use a capital S and type the word system in. What that means is that we are working with a class that is called system. It is part of the Java language, and so it is built into our system. Within that class, there is an instance variable that we're going to access using the dot notation in the same way we do in Python. And that the class that we want is called out. You can see that I have some context menu pop up as Eclipse tries to help me write my code. I can either type out or I can use the arrow keys and go down, select out and hit enter to have that typed in for me. This is referencing an instance variable, which is of a class type called print stream. Don't need to know that necessarily for now. But that class has a method in it. You can see all the methods that are in it by hitting the dot and then seeing the context. I'm going to hit a P, and that's going to filter my context menu so that only those methods that are relevant to a P show up. I'm going to print, and I'm going to type print ln, which is shortcut for print line. That's the name of my method, and now I'm going to pass it some parameters using parentheses, and the main parameter that I'm going to pass it is a string. Strings in Java are indicated with double quotes. Python, you could use single quotes or double quotes. In Java, you only may use double quotes. And I'm going to type in the canonical hello world. All lines in Java end with a semicolon. And so you can see that Eclipse is highlighting this line as having an error in it. You can see the error over on the left indicated by the red circle. And if I hover over that, I'll get indications about what the error is. And if I take the time to slow down and calm down and look and see what my tools are telling me, I get a lot of information about how to fix this error. If I look and I read that, I can see that it says that there are multiple markers at this line. That means that there's more than one error that the Eclipse compiler is finding for us. And the first one says that there's a syntax error. And lo and behold, it's actually telling me how to fix that error. If I take the time to slow down and look at what my tools are telling me and try to understand what's happening in my code. A lot of times I find that with the way in which we interact with social media and the way we interact with Google search, we have a tendency to just click madly, hoping that our error will go away without understanding the source of our error or really what's going to fix our error. So it says here that in order to fix our syntax error, we can insert a semicolon. The reason why Eclipse doesn't do this automatically for us is because that might not be the right way to fix our error, but it seems to be the way in which would be the easiest way. So I'm going to go ahead and hit the semicolon and see what happens. All the errors are resolved when I fix that one error. And so, great, we're in good shape. I'm going to save my program. If I look at my tab, there's a little asterisk next to the title of my file here. That means that it hasn't been saved yet. And I can save my file by going over here to the disk icons, either hovering over my icons to see what they mean. I can either save this individual file or I can save all open and unsaved files. And I'll just save all of them there. After I've saved all those files, you can see that the icon grays out. Oh, maybe you can't see it when I'm zoomed in. Let me zoom out real quick. All right, that save icon was located up here on my Eclipse browser. All right. Okay, actually, let me go back to big screen view so you can see what's happening. To run this, my preferred way of running is to go over to the file that I want to run in the Package Explorer, to right click so I get the context menu, to roll down to the Run As, and to hit Java Application. When I do that, I will see that in my Java console down at the bottom of my Eclipse IDE, I'll see the output of whatever my program ran. And so my system.out.println program printed hello world. Today, for the class work, what I would like you to do is modify this simple program so that instead of printing out hello world, it prints out your name. Run it, make sure you don't have any syntax errors and correct any that you do. And when you're ready to, take the source code file and upload it to Canvas in order for me to evaluate it and to give you the grade. How do you find the source code file? Well, there are a couple different ways. One way in which you can do that is to come over into the Package Explorer. You can right-click on the file, helloworld.java, and you can go down to the context menu where it says Show In. And this will give you a bunch of different ways of viewing this file, the location of the file, the content of it. But the one that you're looking for is System Explorer. And what System Explorer is going to do is it's going to leave the Eclipse environment and it's going to go to your native operating system File Explorer so that you can find where that file is on your hard drive. When I open it, it'll open a Finder window in Mac, and I have an automatic window repositioner, so it jumps up like that. And I can see that here's my file on my hard drive. In Mac, in order to figure out where this is, you can change your view so that you can see the different locations where it is. You can right-click here, and you can see the path to where that file is located. In any event, now you have access to this file, and you can submit it in Canvas when it comes time to do that. That is what I would like to cover for today. That is going to be the extent of what we're going to talk about in lecture for chapter 1. So you're going to have to do some additional work in order to be ready for all of the questions that are going to be asked of you in Techne 1. And you're going to have to do some additional work in order to complete the programming assignment number 1. I'm available in office hours if you would like to go over that with me. And if you have any questions, now would be a great time to ask them. I'm going to let Dodger loose so that he can come around and say hello if you're interested. You are you're dismissed, but I'm going to hang out here and answer any questions that you have. I'm going to go off audio in YouTube so that I can answer specific questions. Thank you for your attention. Okay, that's it for class today.